Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook, this one little Surds slip lost more marks than any other on last year's higher paper. Students wrote 6 root 2 as 12 root 2 and didn't spot it. It seems tiny, but that small mistake cost method marks and confidence. Sound familiar?
Yeah, I've seen that. You think it's fine until you check it, and then it's too late.
Exactly. So today, Surds and Indices. One topic, 2 worked examples, 1 quick win you can use in 10 seconds. No heavy jargon at the start, just simple steps you can hear and follow.
The concept. First, what is a surd? A surd is a root that can't be written as a simple whole number times a root-free integer. In plain language, it's a square root that won't tidy into an ordinary number, like root 2. We keep surds in root form to be exact. Now, indices. An index is a power. Fractional indices represent roots. For example, x to the 1/2 means root x, and x to the 3/2 means x times root x. Negative indices mean reciprocals, so x to the -1 is 1 over x. Keep that mapping in your head. Fractions mean roots, negatives mean flips.
Worked example 1. Simplify root 72. Step 1. Factor the number under the root. 72 equals 2 times 36, but I prefer prime factors. 72 equals 2 cubed times 3 squared. Why prime factors? Because roots care about pairs. Every pair of the same prime comes out of a square root as a single prime on the outside.
So write 72 equals 2 cubed times 3 squared. For square roots, each pair of a prime yields one of that prime outside the root. The 3 squared is a perfect square. That gives 3 outside. From 2 cubed, we get one pair 2 squared, which comes out as 2, and one leftover 2 stays inside as root 2. Multiply the parts outside. 2 times 3 equals 6, so root 72 equals 6 root 2. Why that works with indices, root 72 equals 72 to the power of a half, equals 2 cubed times 3 squared to the power of a half, equals 2 to the power of 3 over 2 times 3 to the power of 2 over 2, equals 2 times 2 to the power of a half times 3, equals 6 root 2. Let that sink in.
Quick check. So whenever there's an even exponent under the root, it all comes out, and odd exponents give one left over inside?
Exactly. Even powers come out fully, odd powers leave one copy inside. That's the prime factor approach. Reliable and fast.
Worked example 2. Simplify x to the 3 over 2 divided by x to the 1 over 2. This uses the index law for division. Subtract exponents. So x to the 3 over 2 divided by x to the 1 over 2 equals x to the 3 over 2 minus 1 over 2 equals x to the 2 over 2 equals x to the 1 equals x. Conceptually, you're cancelling one root x from the numerator and denominator. Another way to see it, x to the 3 over 2 equals x times root x, and x to the 1 over 2 equals root x, so the root x cancels, leaving x. Short, neat, and why the subtraction rule is the same idea as cancelling common factors.
A brief note on domains. For fractional powers, we usually assume the base is positive, so we stay in real numbers. For GCSE Higher, if the question doesn't say otherwise, you can assume positive bases when using fractional indices. Don't overcomplicate it in an exam unless the question flags negatives.
Exam technique. What the examiner wants to see. Clear method, any reasonable working shown, and the final simplified surd or simplest index form. Mark schemes award method marks for correct setup and method, and accuracy marks for the final simplified answer.
Let's break down marks for our 2 worked examples, so you know where to get credit. Example 1. Simplify root 72. Typically, that would be a 2 or 3 mark question. Mark breakdown. M1 for showing the factorization or extracting a square, for instance writing 72 equals 2 cubed times 3 squared, or 72 equals 36 times 2. M1 for taking out the pairs correctly, and A1 for the final simplified surd, 6 root 2. If you write 6 root 2 straight away without showing any working, and the marker can't see your method, you risk losing a method mark if your answer is wrong.
For example 2, x cubed to the power of a half divided by x to the power of a half. That's often a 2-mark part. M1 for applying the index rule and subtracting exponents, A1 for the final x. If you show x to the power of 3 over 2 minus a half to x to the power of 1 to x, that's the chain examiners want. Write it down, don't just think it.
Common errors that lose marks: not simplifying fully, leaving root 72 as root 36 times 2 without writing the outside factor, incorrect prime pairing, cancelling incorrectly when dividing indices, for instance subtracting the wrong numbers, and skipping steps entirely. Examiners love to reward partial credit, so even if you can't finish, show the factor pairs or write the index subtraction. Marks are there for the taking.
So what's a quick win I can use in an exam when I'm rushing?
Quick win. A 10-second check routine. Step 1. Prime factor the number under the square root, or look for perfect square factors. Step 2. Pull out every pair of equal primes. Step 3. Square your simplified result quickly to check. Example: if you get 6 root 2 for root 72, square it in your head. 6 root 2 squared equals 36 times 2 equals 72. If that equals the original number, you're correct. Memory cue: pairs come out, singles stay in. For indices, when dividing, subtract; when multiplying, add; when flipping signs, take reciprocals. Another 10-second check. Convert your surd result back to an index form and verify the power arithmetic.
A small exam habit that saves marks. Always write one line that shows your index manipulation. For example, x to the 3 over 2 divided by x to the half equals x to the 3 over 2 minus the half. That single line often wins you the method mark even if you panic afterwards. Write it down, don't just think it.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.
Bonus practice walkthrough. Try this now with me. Simplify root 72 plus root 8 divided by root 2. I'll pause so you can work it out step by step. First, simplify each surd separately. Root 72 we did 6 root 2. Root 8 is root of 4 times 2 equals 2 root 2. Write those down.
Good. Combine the top. 6 root 2 plus 2 root 2 equals 8 root 2. So we have 8 root 2 divided by root 2. Now cancel root 2. Division of surds cancels common roots. Leaves 8. Final answer 8. Quick verification. Replace root 2 with 1.414 in your head. Numerator: 6 times 1.414 plus 2 times 1.414 equals 8 times 1.414. Divided by 1.414 gives 8. Marking rubric for that practice: M1 for simplifying each surd correctly, M1 for combining like surd terms, M1 for cancelling the common surd, A1 for the final simplified integer 8. So up to 4 marks. Show each line and you bank method marks even if arithmetic slips happen.
Final tip before we go. When in doubt, prime factor the number under the root. Write one clear line showing the index law you're using and do the 10-second square check. Those 3 small habits convert uncertainty into marks every single time. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.